Evaluate integral over c dz by z square plus 4 the whole square, where c is the circle mod z minus I equal to 2. Okay, so here the given integral is integral over c dz by z square plus 4 the whole square. Okay, so now I am going to use Cauchy integral formula. For this, to evaluate this integral, I am going to use Cauchy integral formula. Okay, first I want to find out the singular point. The singular point is by equating denominator 0. So put the denominator 0, z square plus 4 the whole square equal to 0, which implies that z square plus 4 equal to 0, which implies z is equal to plus or minus 2i. Okay, because z square equal to minus 4, then z is equal to plus or minus 2i. Okay, there are two singular points. One is 2i, another one is minus 2i. Next, I want to verify which are lies inside the circle or which are lies outside the circle C. Okay, so now first I am going to take given circle. The given circle is mod z minus 1 equal to 2. First I am going to verify with z equal to 2i. Put z equal to 2i. So modulus z minus I equal to modulus 2i minus I equal to 2i minus I is I. Modulus of I is 1, which is less than the radius, because radius is 2. Okay, which is less than the radius. Therefore z equal to 2i lies inside the circle C. Circle C. Okay, so next I am going to verify with z equal to minus 2i. So put z equal to minus 2i. Then modulus z minus I equal to modulus minus 2i minus I equal to modulus minus 3i. Modulus of minus 3i is plus 3, because you see modulus of 0 plus ib. What is modulus of 0 plus ib? Because here there is no real part, so that's why you can take 0. Okay, so root of real square plus imaginary square. Okay, root of b square is b. Okay, so that modulus of ib is b. Similarly, here modulus of ib is b, but modulus value means negative will be positive. So now which is greater than the radius? Therefore, z equal to minus 2i lies outside the circle C. Circle C. Okay, so now only one singular point lies inside the circle C, another singular point lies outside the circle C. Okay, now I am going to take given integral. What is the given integral? Integral over C dz by z square plus 4 the whole square, and which is equal to integral over c dz by this z square plus 4 can be written as, because the z square plus 4 having the roots plus or minus 2i. So this z square plus 4i can be written as z plus 2i into z minus 2i, but having power 2, so that put power 2. Okay, so now one term lies inside the circle, another one lies outside the circle. Which one lies inside the circle? 2i lies inside the circle. So if it is z equal to 2i lies inside the circle means take the 2i this side, z minus 2i. So z minus 2i term lies inside the circle, z plus 2i term lies outside the circle. So outside the circle term take into numerator. Okay, so integral over c dz by z plus 2y the whole square, you take into numerator, whole divided by z minus 2y the whole square. Okay, so now I want to apply Cauchy integral formula now. Okay, so this is Cauchy integral formula for derivative. Integral over c f of z by z minus a the whole square into dz equal to 2 pi I by 1 factorial into f dash of a. You see, this is very important. The formula is, if you have power 2, then it is 1 factorial 1 derivative. If it is 3, 2 factorial 2 derivative. Okay, so we can generate so many formula like this. But here we have the denominator power 2, so this is the formula. Okay, so what is the formula? Integral over c f of z by z minus a the whole square. What is the formula? 2 pi I by 1 factorial into f dash of a. What is a here? A is 2i. Take this is equation number 1, where f of z is equal to, what is f of z? The numerator term except dz is f of z. So what is the numerator? dz by, so leave it dz, 1 by z plus 2y the whole square. 1 by z plus 2y the whole square. So this is f of z. From this I want f dash of 2y. First I want to differentiate. So differential f dash of z is equal to, so what is the differentiation of this? We can apply u by v method, or otherwise we have a simple formula. Differential of 1 by x is minus 1 by x square. Similarly, differential of 1 by x square is minus 2 by x cube. Okay, so here I am going to apply second formula, because differential of 1 by x square. What is the differential of 1 by x square? Minus 2 by x cube. And the differential of inner term is 1, so we don't want to differentiate. So this is f dash of z, but I want f dash of 2y. So what is f dash of 2y? Is equal to minus 2 by, put z equal to 2y, 2y plus 2y, 4i. So 4i the whole cube. So minus 2 by 4 cube, 64. And I cube, what is I cube? I cube is I square into I square is minus 1, so minus 1 into I minus I. So this is I cube. Okay, so I cube is minus I. So finally f dash of 2y is equal to, minus minus cancel, 2 also cancel, so 1 by 32i. Okay, so this is f dash of 2y. Substituting in 1. So what is the 1? This is 1. So our required integral we will get. So 1 implies that our required integral over c dz by z square plus 4 the whole square is equal to 2 pi I by 1 factorial into f dash of 2i. What is f dash of 2i? 1 by 32. 1 by 32i. So I cancel, 2 also can be cancelled. So the answer is pi by 16. So pi by 16 is the answer of the problem.